All right, hello, good morning. My name is Teacher Ryan, and today we're going to talk about chemistry. Welcome to my class. It's a pleasure to meet you. In this video, we're going to talk about significant figures and scientific notation. This is how chemists are people that do chemistry, right? Or they are scientists that study chemistry. This is how chemists do math, right? Right? You take a math class and you learn how to do math. In chemistry, we have a way to do math that's a little bit different than your math class. And we are focused on things that are significant. Significant. Repeat after me, significant, right? Significant means important. These are things that are important. Significant means important. If you are not sure what significant means, go ahead, stop the video and open up Google Translate and find out what does significant mean. Important. The other word here is figure. Figure is a fancy word for number, right? Numbers. Numbers like 1, 2, 3, 4. But it means more than just that. It is a digit, right? So when I'm going to say a lot in this video and in the science classes at Saad, I'm going to say a lot about count the sig for significant, count the sig figs. And fig means figure, right? SIG and FIG. Count the sig figs. And I want you to make sure that you know what numbers are important when doing your math. So we're going to talk about that in this video and learn about the rules for significant figures, or like I say it, sig figs. Repeat after me, sig figs. Great. Let's go ahead and get into the video. And then at the end of this little pre-course, we're going to study about scientific notation. Let's learn about sig figs. Let's go. So remember, sig means significant and fig just means number, right? So number, and significant means something that is important, right? Scientists, right? People that study science, or chemist or biologist, use significant figures to determine how precise a measurement is, right? Well, this is a beautiful word, precise. Repeat after me, precise. Right, perfect. Precise means something that you know for sure, right? You know something that you know for sure, for 100% sure. You are precise. You know exactly. So you can think of precise as well as exactly. You know exactly that this, that something is true. You know that something is true. You know for sure. That's why scientists like sig figs, because scientists like to know the truth, right? That is science, where we want to know what is true. So when we do our math, we want to be precise and know that's what is true. So what we do is sometimes in our math, we will get a measurement. And a measurement is something you get from a ruler or a scale, or there's many things, a thermometer. You get these from many different objects in the science lab. So you get significant digits or numbers. Digit means number. In a measurement, include all of the known, this is what you know, known digits. Remember, digits mean number, plus one estimated digit, or you have probably studied this, called rounding. So we're going to round the last digit. So all the digits we know for sure, the significant ones, plus one that is rounded. That is, we know exactly. So here we have a ruler. This is a ruler, and this is a tool to measure. A tool to measure. So if we look at this ruler, you might want to know that each line on this ruler is 0.1 centimeters, right? So that's the measurement that's being used. So this is 8 centimeters right here. Then we have 9 centimeters and 10 centimeters and so on and so forth. And these lines here, this line, this line, this line, this line, this line is 0.5, right? So 10 of those equals 1 centimeter. Beautiful. So I want you to know that you can read the arrow. You can read that the arrow right here is on 13, right? 13, so we know for sure. These are precise, so these are significant. 13.3, right? 13.3 centimeters. However, using significant figures, you must estimate you can think of as guess the next digit, right? What do you think that next digit's going to be? You must guess it. So what we're going to do is we're going to say that it is a 0. We're going to say 13.30 centimeters after our guess. Now look at the ruler below and go ahead and give it a guess. Where is this arrow now? Where is the arrow now? I have it in red. Where is that arrow pointing? Can you estimate? Can you read before you estimate? What do you read? You probably read 12.8 centimeters, right? Very good. 12.8 centimeters. But now with significant digits, you want to estimate that last digit. So we're going to estimate the next digit or number. And when we estimate it, it is 12.85. 12.85. So we give it that extra one to account for the precision in our ruler. The same rules apply with all instruments, and different instruments, like we just talked about. We had the ruler. We had, go back. We had the ruler. We had a ruler. Maybe we'll have a scale, or we'll have a graduated cylinder, right? All of these things we'll use as tools to measure our product in the science room. Go ahead. We're going to do this one. Go ahead, take a guess at what you think this number should be. All right, so maybe you've already have a number in mind. Let's go ahead and look at it. So the units, if you're wondering, the units for this will be milliliters, right? 1,000 liters, milliliters. So what can you read with confidence, right? That's my question for you. What can you read with confidence? Meaning you are sure. Sure, confidence means you are sure about it. You can read that you have 56, right? So you have 1, 2, 3, 4, 5. So this is 55. And then you know that this would be 6, right? The next tick or the next line would be 56 milliliters. Now I want you to estimate the last digit, the last number. What would that last digit be? Do you have a guess? If you are thinking 56.0 milliliters, you are correct, right? Congratulations, good job, guys. One more graduated cylinder, look at it below, and then go ahead, give me the number that you would give this measurement on the graduated cylinder. In case you take a moment, go ahead and get it. If you want to know that we use graduated cylinders to measure liquids, right? We use this to measure liquids. All right, what do you have for that measurement? Let's go ahead and look. We have 35 are 53.5 milliliters. Because we know that here we're at 50, this would be 51, this would be 52, 53. So we know for sure we're at 53, and we're going to estimate the last digit and say it's 5. So 53.5. This is as precise as we can go. We can't go to a second digit. We can only have one digit after that decimal for this unit, for this measuring device. All right, let's go ahead and learn rules for significant figures. Rule number 1. All non-zero digits are always significant, right? So non means not, right? Non means not. And if you're maybe just learning English and you're having some problem, that means my, right? Not means that it's the opposite, right? So non-zero, right? Zero is simply a number. Digits, and remember, digits means numbers. So anything that is not zero is always significant. Let's take a look at the following numbers. I want you to count how many significant digits there are in the following numbers. This number, how many significant digits are there? 274 is the number, but how many digits are there that are significant? 3, right, good. Because 2 is a non-zero number, 7 is a non-zero digit, rather, and 4 is a non-zero digit, right? So we have 1 digit, 2 digits, and 3 digits. So we have 3 sig figs, or significant figures. That's easy, right? Let's give it another try. Look at this number and count all of the non-zero digits and how many digits are significant. Give it a try. What are you thinking? Let's go ahead and see the answer. The answer is 5 sig figs, or 5 significant digits. We have 1, 2, 3, 4, 5. Do you see a 0 here? No, there's no 0. So they are all significant digits. Let's give another one a try. 8.987. How many significant digits are there in this number? Give this one a try. Do you have a number in mind? How many are there? I'm excited to see what you have to say. 4. Right, were you thinking 4? You are correct. That's very good. There's 1, 2, 3, 4. What's the rule? All non-zero digits are always significant. So if you see a 0, that's when you have to think, is it significant or not? If it's a 1, significant, always. If it's a 2, always significant. If it's a 7, it's always significant. Let's take a look at rule number 2. Rule number 2. All zeros between, what does between mean? Don't come, right? All zeros between significant digits are always significant, right? So if you have non-zeros, digits, and a 0 in between them, they're significant, right? The zeros are significant. So this is when the rule is going to become a little bit harder, because we're going to talk about zeros. Let's look at some examples and count how many significant digits are in the following numbers. Here we have 504. How many significant digits are there? Remember the rule. All zeros between, don't come, significant digits or non-zero digits are always significant, are always important, So let's go back down and see, what do we got here? What is your answer? What are you thinking? So I see a total of 3. Could all three be significant? Let's see. Yeah, all three are. So we have 5 and 4 are always going to be significant, important. The 0 is between the significant digits. So 0 is significant as well. Therefore, we have 3 significant digits. Let's take another example and give it a try. We have the number 60,002. 600002. How many significant digits are there in this number? There's a total of 5 digits. Are 2 digits significant? 1 digit significant? Or all 5 significant? Remember the rule. All non-zero digits are significant. Rule number 1. Rule number 2, all zeros between significant digits are always significant. So what's our answer? 5. Good job if that's what you were thinking. Maybe you were thinking it was 2, right? Maybe. Yeah, 6 and 2 are for sure significant. So good job there. But what you need to remember is that all these zeros are between. And between means 동간, right? So it's between. So all those zeros, yay, we love zeros, are going to be significant. So we have 5. Let's give it one more try and another example. Are you ready? Let's see. Go ahead, man. This is awesome. Give this one a try. 9.077. How many significant digits are there in this number? Remember, rule number 1, all digits that are not 0 are significant. Rule number 2, if you have a 0 and it's between a significant digit, it is going to be significant as well. Let's give it a try. I see a total of 4 digits. Is 1 digit significant? Are there 2 digits that are significant? Are there 3 digits that are significant? Or are there 4 digits that are significant? Give it a try. What are you thinking? Let's see the answer. Aren't you excited for the answer? This is awesome, guys. I'm having so much fun. I don't know about you, but this is amazing. All right, you ready, Teacher Ryan? Let's give them the answer. The answer is 4, right? The answer is 4 because is 9 significant? Yeah, non-zero. Come on, teacher. Is 7 significant? Yeah, it is. It's not 0, so it is significant. That's easy. 7 is also a non-zero digit, so it is significant. And then we have a 0 between significant digits. So this 0 is significant. Therefore, we have an answer for significant figures. All right, guys, we're going to stop there at rule 2, and we'll pick up at the next class on rule 3. Go ahead and do your assignments. And if you have any questions, let me know. Have a great day. It was good talking to you. See you later.